Okay guys, it's Mr. Dorsey. I want to give you an example since it's been a little while over the break since you've done these, but I want to give you an example of an addition equation so that you know how to do the ones on the in-class work. So let's go ahead and do this one together. First thing you want to do always is what? Isolate the variable. That means get the variable by itself. And how do we do that? The variable's on the right side in this equation. Doesn't matter if it's on the right or the left. All I have to do is figure out if I'm adding 5 to t to get t by itself, I must subtract 5 from this side, and I must do the same thing to both sides, which we remember is the golden rule of equations, right? So I'm going to go ahead and do that. Now we're going to show this like I taught you in class. So if we have t plus 5 minus 5, that simply leaves us with t. That was the whole reason we did it, to get t alone. And 11 minus 5 is 6. So 6 equals t, or t equals 6. That is our final answer on that one. Okay, let's take a look at this example of a subtraction equation. R minus 7 equals 1. Same situation exists here, except rather than doing addition to begin with, we're doing subtraction. And you have to think to yourself, right, how do I get the variable alone, the r? I'm subtracting 7, so in order to get it by itself, I have to add 7. R minus 7 plus 7 is r. So we're going to have to add 7 to both sides. So again, I'm going to draw this line down through the equal sign. And then I'm going to do the same thing, the golden rule of equations to both sides. R minus 7 plus 7 is simply r, and 1 plus 7 is 8. Now your check for this, by the way, I didn't say it in the first problem, but your check to make sure that this is correct is you stick 8 in for r. 8 minus 7 equals 1, and that's correct. Okay, let's take a look at this example of a multiplication equation. 3x equals 15. Sorry, underneath my paper there's a bump or something. 3x equals 15. So again, you're going to think to yourself, what's the opposite of multiplication? So I can undo the multiplication to get the variable alone. Opposite of multiplication is division. So again, you want to draw this line down the middle, and then you want to divide the left side by 3 and the right side by 3. So if we divide both sides by 3, we get x equals 5. Okay, let's take a look at this example of a division equation. X divided by 7 equals 49. You could see it either written with a normal division sign like you were used to. It could be like this. But in algebra, you'll start to see it more like this, with the fraction line, the fraction bar. So that means the same thing. So you have to ask yourself, excuse me, you have to ask yourself, what's the undo operation for division? And we know that it's multiplication. I'm going to show the same work here. X divided by 7, I must multiply both sides by 7 in order to get rid of the 7 over here and get the x by itself. So let's do that. I'm going to put times 7 over here and times 7 over here. And these cancel out. The left side simply becomes x. And the right side becomes whatever 49 times 7 is. I don't have that number handy in my head, so I'm going to go ahead and do the long math, which you guys should too. And if I do that, 7 times 9 is 63. Regroup the 6. 4 times 7 is 28. Plus 6 is 34. Should be 343 if I did the math correctly. 3, 4, 3. That's our final answer. By the way, up here on this, I forgot to circle my answer. Get in the habit of circling your answer. It makes it just easier to follow your work. So in the in-class notes of what you guys are doing, you're gonna do this on loose leaf in addition to answering the questions on the form that I made for you. Okay?